Let's do another example problem thinking about the interval of convergence and radius of convergence. So here's a reasonable kind of power series, I guess. How are we going to find the interval of convergence, the radius of convergence? What set of x values make this infinite sum converge? Ratio test, maybe that's a pretty good tool for power series because they often involve factorials, so we can't use the integral test. They often involve power functions like this, which work reasonably well. We get nice cancellation with the ratio test. So let's try ratio test. So again, we'll do this term underneath the next term. And remember, we have to include this x part, so we have to be careful about, I'm not writing a sub n plus 1 because we said before that would kind of just be this part, but we won't want to include the entire term. So we'll do root n plus 1 times 1 over 8 to the n plus 1, x plus 6 to the n plus 1, over root n times 1 over 8 to the n times x plus 6 to the n. And what do we get if we start canceling terms there? We get square root of n plus 1 over n. The 8 to the n is in the denominator of the denominator, so we could write that in the numerator. 8 to the n plus 1 is in the denominator of the numerator, so we can write it there in the overall denominator. And then we have an n and an n plus 1. We could move this up as a negative n, and then we get negative n plus 1 minus n, which is just 1. So we get x plus 6. We can simplify that a little bit. We get n plus 1 over n. We get a 1 over 8, x plus 6 there. So what do we need this to be for the ratio test? It says the sum converges if, and again, we didn't have any alternating here, but we weren't thinking about, well, x plus 6 could be negative, and then that would induce alternating signs. So overall, we can just put absolute values on it. We forgot, let's see, I'll say the limit is, what, less than 1. What is this limit? It's, so we're taking n to infinity. This term, again, gives us like a billion plus 1 over a billion, which is basically 1. So we're getting square root of 1 times 1/8 times, and then this x plus 6, the n doesn't affect that, so I just copy it. So the sum converges if the absolute value of that thing, I'll leave off the square root of 1, is less than 1 and diverges if that absolute value is greater than 1. So what range of x's satisfies this? Let's write it this way. If something's absolute value is less than 1, that means that it's between -1 and +1. Let's multiply each part by 8. And we get -8 less than x plus 6 less than 8. And then divide and then subtract each 6 from each part. So -8 minus 6 less than x less than 8 minus 6. -8 minus 6 is -14. And 8 minus 6 is 2. So that would be our interval of convergence. From -14 to +2. Again, we should check the endpoints, but we're gonna, if we were pure math people, we would definitely check the endpoints. But we're gonna skip over that part here. Let's diagram what's going on here. We've got -14, let's go -12, -10, -8, -6, -4, -2, 0, 2. So that's our interval of convergence. What's our radius of convergence? Well, what's the you could say take the whole width is 16, and then take half of that, so the radius of convergence would be 8. So let's say what we did there. We did the upper end minus the lower end, the lower end itself being negative 14. So we got 16 over 2, which is 8. So we've got, we're centered at negative 6, and we can go kind of plus 8 and minus 8. And that makes it look a little bit more like a radius of convergence.